All right. Okay, cool. All right, gonna get started. Is that up there? Oh, it is. Cool. All right, howdy, everybody. So I'm Ben. Like they said, I am the Chief Analytics Officer and one of the co-founders of Mode. And I'm going to talk about the data scientist's hierarchy of needs. So a little bit of background about myself. So I founded Mode. Mode is an analytics and data science and BI platform that's built for analysts and data scientists to be able to create work and distribute it around their organizations. So it looks a little bit something like this, where people can write SQL queries and build things on top of that. There's also integrated R and Python notebooks for people to be able to work into, as well as some like drag and drop visualization tools. So it's kind of this all-in-one package for analysts and data scientists to be able to create work and distribute it around their organizations. So it's used by a bunch of different data science teams and analytics teams and a bunch of different companies. Here's kind of the obligatory marketing, put up a slide of our customer slide. And so one of the things, though, that's interesting about this is, why do these folks use it? When we're building this product, we want to understand, what is it that actually makes these companies choose Mode over other products? So we, like any software company, go out and do surveys of our users and ask them kind of what is it you like about the product or what is it you don't? And one of the things that's really interesting is that the answers that we consistently get are things like this. There are things like, it just works the way I want it to, or it handles all the annoying parts of my analysis, or the UI and the platform as a whole are really intuitive. So you hear things about kind of the overall experience of the platform and the way it works into their day-to-day. They're not necessarily describing individual features like Jupyter Notebooks or like APIs or things like that. We also hear this on the flip side, so occasionally people do come along and say there are things they don't like. And so when they say that, again, they're usually not complaining about particular features as much as they're complaining about kind of the overall experience, if they feel like it's unintuitive or it's not as flexible as they want it to be. And so one of the things this tells us as we're building products is the overall experience of these products is much more important than the features themselves. The individual features don't matter nearly as much as the context in which they're built and the kind of connotation of that product. Like, does it satisfy the needs of data scientists in the way that they work and the way that they think? And so the interesting thing is, when we also talk to companies, we talk to them a lot about building their data teams and how are they trying to build data-driven cultures. And so in those answers, we actually see a lot of the same things. So these are actually not from conversations that we had, but these are from Glassdoor reviews of the data science team at Facebook. And some of the really good reviews say things like this, where they say, why do you like working at Facebook on their data science team? Because it's challenging and engaging and supportive. Because there's influence and autonomy and it's convenient. Because there's challenging problems and it's impactful. Or the people who don't like working at Facebook, why do they not like that? It's focused on short-term impact. They have shorter-term review cycles and they don't like that. Or there's not as much clarity around expectations. And again, when thinking about building out these teams, the things that people are expressing about what they like or what they don't like and working for companies isn't the job description. It's not the experience of we work in this technology stack, or we're supposed to do this, or we're supposed to do that. It's the experience of working in that job. It's the overall package, and again, kind of the connotation of the way that they work, rather than, I don't like this particular tool that they chose to use, or I don't like that I have to work with this team, or I have to work on solving this problem. And so why does all this matter? When we think about building products for data analysts or data scientists, when we think about building data-driven companies and building experiences for them at our companies where we work, we think it's really important to think about what matters to data scientists and data analysts as people, as the experiences they're looking for, not what are the tools that they want to use or what are the problems specifically they want to work on. And so that's what I want to talk about here is what really matters to data scientists. Data scientists here immortalized by Jonah Hill and Moneyball. And so I want to talk about what are the things that actually matter to them as people? What is it that motivates us to do the jobs that we do? What do we like? What do we not like? What skills do we bring? And what is it that really makes us excited to be working at particular companies or working on particular jobs versus less so? And the framework that I want to use for this, some people may have seen this before. It's Maslow's hierarchy of needs. It's designed for people in psychology. So we're going to apply it here as kind of the framework for how data scientists think about their day-to-day and their jobs and the ways in which they kind of contextualize their work. So to go through this, we'll just start at the bottom. What are these physiological needs? So by this I mean, what are the things that we need to do the job? If you're a data scientist, what are the sort of required skills or required ways of thinking that you have to actually be able to do the job that you need to do day to day? The first thing, and this may be like an obvious thing, but is what actually is the job? One of the things that's really hard about being a data scientist is that means a ton of different things, that nobody has a clear definition of what a data scientist actually is. At one company, it means one thing. At another company, it means something else. And so if we're a data scientist somewhere, one of the most critical things is actually understanding what it is we're supposed to be doing. So if you Google data scientist versus these things, you'll see it's like people are trying to figure out what is a data scientist versus an analyst versus a quant versus a research scientist versus business intelligence. All of these things are things that people don't quite understand what it means because the industry hasn't done a particularly good job of defining these terms. To make it more complicated, some companies are also trying to redefine these terms to either fit one within recruiting, to make recruiting easier, or to fit within salary bands. So data science at Lyft actually recently rebranded data analysts to be data scientists and data scientists to be research scientists. You may be asking again, what do these people do? What is a research scientist that used to be a data scientist? Nobody really knows. This is actually my LinkedIn page. I used to work at Microsoft and Yammer, which was a startup that was bought by Microsoft. I was effectively a data scientist or data analyst. I don't actually know which one, but my title was a quantitative product analyst and a product intelligence manager. So these were the titles that Microsoft was using to actually describe this role. And again, it's not a lot of clarity in terms of what these things mean. And so the first thing that we really want to think about if we're in this role is what is our actual job? What is it that we're trying to do? And really, if we break it down, there are kind of two main roles that people in these roles play, and two main jobs they're trying to help people get done. The first is helping people make big decisions. So this is helping the organization make strategic decisions about what we should be investing in, what we should be doing, what we should not be doing. Some examples of this are things like, do we as a company, do we build product A or do we build product B? Do we expand internationally? Do we hire more salespeople? Do we let go of salespeople? Do we close down a product line because it's not performing? Do we spend more on Facebook ads? Do we sponsor a conference like this? Do we market to a new audience? Maybe we're trying to expand to new geos. Do we sell the company? These are all things that are big strategic questions that businesses are trying to answer, and they want to be data-driven about it. And so they'll often turn to analysts or data scientists to be able to say, hey, how should we make these decisions? Is it a good decision for us to sponsor this conference? Is there ROI on that decision? As an example of that, this was something we actually internally talked a lot about recently at Mode. We recently made a freemium version of Mode. This was obviously a very big decision for us as a company. We wanted to invest in, is this the right thing? What do we think are the effects of that? And so this was one of the examples of how data science really helped us make that decision. We did a bunch of analysis on what would happen if it's free, what customers do we lose to cannibalization, which customers do we add, what's the value of those free customers. And so this was one of the roles that our data science team played. The other big role that data science teams often play is they help automate frequent decisions. So these aren't helping the company or individuals or decision makers of the company decide something. This is helping a machine decide something very, very frequently. So there's lots of examples you can think of this, of which clothes do I put in a Stitch Fix box? If I'm a self-driving car, do I turn left? Do I stop? Do I turn right? Do I go straight? If I'm Facebook, which ads do I surface to somebody? If I'm Netflix, we saw some of this earlier this morning, which pictures do I show to an individual? There are also more sort of physical applications of this. There's a company called Blue River Technology that helps tractors identify what are weeds and what are actual plants so they can spray pesticides on the weeds as tractors drive over it. Or things in politics. Who do I call that's most likely to give me a donation on a campaign? All of these things are, again, helping machines make these decisions very, very quickly so that you can do them at a very massive scale. And so the tricky part is these two jobs are often things that feed into the data scientist title. And so if we're trying to help people make decisions or trying to automate frequent decisions, it's important for us to know which one we're supposed to be doing. That we can't do our jobs if there's not clarity on which one of these two buckets are we in, or are we in both. And so that's a really important thing for us to be able to be successful. For the sake of this, the rest of this, most of the things I'm going to talk about are around the helping people make decisions. But a lot of these things can also apply to the way that data scientists think in this more ML world of automating frequent decisions. All right, so moving on. So what are some of these other physiological needs that we as data scientists have? One is SQL. So you talk a lot about the technologies that you might need to learn if you go through some sort of boot camp or things like that, where they teach you, hey, here's the skills for becoming a data scientist. You'll learn a lot of the advanced machine learning packages and things in Python and all those sorts of pieces. At the end of the day, most of what data scientists do is based on SQL. SQL is very foundational to a lot of our work. No data scientist I know can actually be functional without SQL. Lots of them can be functional without some of these other tools. And you can actually see this if you look at Glassdoor, which has a lot of these like reviews of job listings and things like that. If you just look at how frequently these words show up, SQL shows up about twice as often as both R and Python in the things that are appearing in these job listings. And so as a result, we use it for all sorts of things. You can see people are using SQL to do analysis, to do ETL, to do machine learning, which seems hard, to do all sorts of stuff. People also just use SQL to do math. So like, it's a really powerful tool. It's the foundation of what most data scientists are using. And so if you're ever thinking about like, what is it we need to enable for data scientists, often providing a clean way to write SQL is really important. The next thing, obviously, as data scientists, we need data, but more specifically, need data for humans. I think that a lot of the data that data scientists work with was either machine-generated, in the case of like logs or things like that, or it was data that was generated by people. If you're looking at like healthcare records, that wasn't designed. That was like designed for who knows what. Like nobody can interpret it. And so, as data scientists, it's important for us to be able to have data that's like usable for us as people. And so what does that look like? So here's an example of things that we commonly see that really go wrong. This is a table that's like my nightmare table. So what are some of the problems here? You'll often see stuff like this, where there are these columns that are all kind of named the same thing, and you're like, wait, what's the difference between these things? One data scientist might use created at for their analysis. One might use started at, and nobody actually knows what the difference is. There may be sometimes like this, where because these things are generated by applications, engineers may name columns things that are actually reserved words in the way that data scientists interact with it. So for instance, if you run this select timestamp query against, I think, Postgres, it won't work because timestamp is a reserved word. So as a result, if your data looks like that, you have to go through all these like hassles to actually work with it. Sometimes engineers or other applications will put like periods in column names. It seems like a trivial thing, but it's really annoying if you're actually working with that data that you have to like quote it and stuff. It really slows down how often you can work on it. Also, you'll see this a lot of people not really naming columns in meaningful ways. I actually like wrote this a week ago, and I don't actually remember what is rep drem means. And so like as a data scientist, you're like, what do I do with this? I don't know. You have to go ask somebody. It's a pain. And sometimes, especially in like more like Oracle or legacy databases, everything will be all caps. And so then you'll have like these queries that are these all caps things. It's super annoying. And then every query you talk about, you feel like you're yelling at it. And it's like, seems like a small thing, but if you live in this, and this is the world that you exist in, it's painful to just type everything in all caps. See, this is how upset I get about this. Okay. So what else? What are some of the other needs that we have? So engineering. So if you see those like sort of Venn diagrams of what is a data scientist, often engineering is on that list. This is a case where actually for a lot of folks, the engineering skills sort of aren't fully there. The way I say that analysts or data scientists often work with engineering is we kind of think of it like the engine of a car. We can kind of open it up, see if something went wrong, tinker with it a little bit, but we're not really the people there to fully fix it. And so I can tell you there's a lot of times when I've been working with folks and you're trying to try to solve some problem or trying to like push something into Git, you'll see scenarios like this where it's like, all right, well, we'll just add it, we'll commit it, let's push it. Okay, oops, we got some sort of like conflict. Well, we forgot to git pull, let's git pull, check the status, nope, doesn't work, pull it again, nope, status, nope, pull origin master, maybe that works, nope, sudo git pull, I don't know. You do all this stuff and like, this is a thing that we do because we don't sort of aren't fully engineers. We're like learning the skill to get the job done, but that's not really where we actually often are. And so it's a thing we have to work around. It's a thing that we as data scientists probably could be better at. But if you're working with us, it's important to understand a lot of us don't come from engineering backgrounds and don't have some of those foundational principles that other folks may have. This got out of order somehow. So another thing that's in that kind of Venn diagram of stuff is statistics. Like how much do data scientists actually work with statistics? According to Quora, apparently all day, that I want to be a data analyst, but I don't want to sit and stare at equations all day. This is apparently how people think that we do our jobs. It's not really the case. So the way that I kind of would say statistics works is it's similar to the way that like engineers would have relationships with algorithms. So there are indeed engineers that work a lot in algorithms that understand them very deeply. Most engineers have some basic concept of what they are, but most engineers aren't sort of algorithm engineers. It's not what they're building. They're building a lot of things around them and just have to have some awareness of how that works. That's often how statistics and data science actually interacts. There are data scientists that live in it. So if you're someone, for instance, who manages a lot of A/B testing, you'll often work in worlds like this, and that's what you do, is you do a bunch of statistical analysis to try to understand sort of complex relationships between things, understand causality, interpret those results in the right way. But for a lot of us, this isn't what we do. We're instead trying to answer questions like this of, what happened to this chart? Like, why are our active users going down? And in that case, if you get a question from some VC that says, like, hey, why are your active users going down? Your response can't be, like, don't worry, it's not statistically significant. Like, that obviously does not work here. Like, the VC is going to be like, all right, go away, I'm going to talk to somebody else. And so statistics doesn't really come into play there. Again, you need to have some foundation of how it works, but we're not like trying to apply everything to some statistical model. The last thing in here is, on this physiological needs, is business expertise. So how do we actually work with like the business side of the house? What level of business expertise do we often bring? In this example, so there's kind of two ways you can think about this. A lot of data scientists have business context. They have domain expertise in the sense they understand the needs of the business. If they work in a healthcare industry, they will often understand some of the ins and outs of that healthcare industry that they have learned on the job. If they're working in software or e-commerce, they'll understand a lot about how that works. But they're often not business experts themselves. So again, if you go back to these Glassdoor job postings and you look at, okay, well, how often is sort of the credentialed business expert a data scientist? If you think about like an MBA, it's not very often. So MBAs are very uncommon, like as things that people want in data scientists. They often assume that the way you can learn this business expertise is through the domain of the business, not through sort of the actual sort of academic side of understanding how businesses work. That's often things that you can learn on the job. And so we're often not like business expertise in this kind of traditional sense. Okay. What if we want to move up the pyramid? So we have now physiological needs. What's next on this is safety and security, by which I mean, like, what stresses us out? What keeps us awake at night? What is it that upsets us as data scientists? One thing is SQL. So we use it all the time. So as a result, we have a lot of opinions about it. If you ever want to like upset a group of analysts, ask them how they format their SQL queries. You will get some answers like this. You will get some answers like this. You will get sane people that say this. We actually, our CEO at Mode actually posted something on Twitter about this, about like, hey, where do you put your commas in SQL queries? It's a very like HBO, Silicon Valley, tabs or spaces kind of argument. But it started like a lot of fighting among data scientists, like, oh my God, I cannot believe you put them at the end of lines. These are the sorts of things we fight about. Again, when you live in SQL, you care about things like this. Other stuff that we stress out about, query speeds. So how fast are our queries running? This is a place where a lot of the technology that folks like y'all build about like speeding up databases and things like that matters a ton to us. So Mode is a platform that sits on top of people's data. Analysts live in it and write queries in it. So we have a little bit of information about how often people are actually writing queries and how much time they actually spend waiting on them. So on average, an average analyst in Mode writes about 160 queries a day. The average runtime of those queries moves around some, but it's about 20 seconds, which means that analysts are waiting roughly 53 minutes a day to be able to get their query results back, which is a lot of time. Like, this is an eighth of our day sitting around just waiting on a spinner for us to return something. And if people can cut this in half, if you can cut it by 20%, it feels much better as we're sitting there waiting 20 seconds 60 times a day. So this is another thing that we try to do a lot around, of how do we optimize speeding these things up? What can we do to make this faster? Next thing that stresses us out is changing data. So we obviously are working a lot with data. We have to answer questions about how thing was before, how thing's going to be tomorrow. And sometimes we'll come across situations like this, where we'll like run a query, select star from users that's got like the beast in it, and it's got Gaston, and they're both active. And then tomorrow run the same query, and now like the beast is gone, and it's just replaced with Prince, and Gaston has been deleted, and we don't know why. And so it's like really stressful for understanding what actually happened. And there's not a lot of great solutions out there for actually enabling people to be able to see what changed in their data. Why did this one metric move from yesterday to today when the underlying data changed? And so this is a place where I think like the industry could go, or have a lot of improvements, is actually doing a better job of tracking kind of what changes in people's data over time, so that when we get these different results and we see something was different yesterday than when we ran the same query before, we actually can understand what it is that actually happened. And this also happens all the time. One of the other things, too, that we can see within Mode is how often people's schemas change. So how often does like a database schema update? The result of that is it's about once every 5 hours. is how often actually databases are evolving. And so that's how often we have to not only deal with like changing data, but even changing structures of data. And so all of those changes are things that can be disruptive. They're things that can change the numbers that we're reporting to our bosses, or things we're reporting to the CEO, or things we're reporting to the board. And with each of those changes, we have to often figure out why. And so anything that we can do to help solve those problems is really helpful. Other things that bother us, so simple questions. So you'll often get very simple questions from VCs, like, what's your revenue? Seems like it should be really easy to add. Just like add up how much money is in your bank account. It's often not. It's often something that looks like this. So this is actually a chart of how people figured out what revenue they should be counting towards actual revenue. I don't remember the company this was from, but like these are the things you often have to figure out. And this is the mess that you're often in when you're trying to answer these very, very simple questions. And this is in part the reason that you get answers like this from folks like WeWork, which is like, this is all the things that they needed to figure out. In WeWork's case, it probably wasn't entirely honest, but you get the idea. Other things, too, that bother us, kind of along the same lines, are dips and dashboards. So not only if data changes is it stressful, but these things also trigger lots of our bosses to come to us and say, like, oh my God, look, our dashboard is declining. Like, is this the end? Are we like doomed? Is this like a trend line that's now we're just going to bottom out? What do we do? And so the way we have to try to solve this is figure out, like, hey, is this a meaningful change, or is it just noise? Is this dip that we just saw, like, the beginning of the end? Are we at the end of this chart, or are we just in this little bump in the middle? And so there's a lot of different techniques that data scientists will try to deploy to figure this out. Some of them are rigorous and statistical to figure out like whether or not it's an anomaly or not. Some of them are just keeping track of things like major holidays around the world. So if you see a dip in active users, it may actually be a holiday in Sweden. And that's why nobody's using the platform that weekend, is because people are off on a holiday. Those are the places where we get nervous. How do we actually then belong? What is it that makes us like work with people and excited to be sort of part of the organizations that we're a part of? So how do we work with others? So one of the sort of hardest parts of being a data scientist, or the trickiest sort of challenges in the job, is delivering results at scale. So if you think about what the job of a data scientist is and the roles of data scientists, there often aren't very many of them in an organization. So there was a kind of informal survey in a community I'm a part of that was asking how many like data professionals are in your organization compared to the entire org. And these were the answers. On average, it's about 4%. And so our job is often to answer questions for those 96% as 4% of the organization. So how do we do that? One way we could do it is we could like build a bunch of dashboards and reports and stuff for everybody anytime they have a request. But that's how you get job reviews like this one, which says basically like, we were stuck doing fundamental work all the time, like monthly reporting. We hated it. It wasn't what we wanted to do. And so as a result, we've often built a lot of tools to enable things like self-serve. So self-serve is essentially saying, hey, you as a business user, here is the data. You can kind of figure out your own conclusions. Take this and draw your own conclusions and make your own decisions. And don't bother us. We're going to work on other things. And so the challenge, though, with this is that the work that data scientists do isn't just about data access. That you can't simply just like self-serve data science. That there's often a skill that goes beyond just like being able to build the charts, but there's a skill in actually interpreting that. And so an example of that, when it was like almost had very disastrous consequences, we were talking to some folks that are customers of ours that were trying to double. It was actually a very large company. They were looking to double their headcount. This was last year, so in 2018, they had some number of employees and they were looking to double it. And so the way they were going to try to figure that out is like, let's look at our recruiting pipeline. Let's figure out who we should hire. Let's make the best decisions about we're bringing on thousands of new people next year. Who are the right people to hire? And so because the data science team was busy with lots of other things, they said, great, we'll self-serve this. We'll give some data to the recruiting team and some of the executives to be able to say, like, draw your own conclusions about who we should be hiring. And so what did they find? They found that getting promoted is good. Like, that's an indicator of someone being successful in the job. So great, let's find people who get promoted. And they found that junior hires tend to get promoted the most. So the company had this proposal on the CEO's desk that was about to get rubber stamped, that they should hire more junior people. That they should just fill the company with lots of junior people because they're clearly the best because they get promoted all the time. Some data scientists came along and said, like, wait a minute, that doesn't seem right. For obvious reasons, like obviously junior people are much more likely to get promoted because they have places to get promoted. It's very hard to promote like a VP of engineering. But it was almost something that the company went off and did. And so this is the challenge that data scientists often face, is how do we not be gatekeepers of data, and how do we help people to get the data they need, because there are so many more people who are trying to get that data than there are of us, but without having these things happen. There aren't great answers to that. I think it's something that people are still trying to figure out. I think one of the really important things, though, is for organizations to try to recognize the difference between what is good analysis and that is done by someone who's deep in the data, and what is more superficial analysis. And I think this is tricky because if you think about other disciplines, if you think about something like design, it's very easy to tell what is good design. If you look at like Stripe's webpage, anybody can be like, yeah, that seems good. And if you look at the California DMV, you're like, that's kind of painful. Similarly with things like marketing, if you're Smith & Liggett, like that's obviously not very great marketing. If you're Nike, everybody can look at it and be like, yeah, I feel that. That's good marketing. If you look at like the results of data science, it's hard to tell. So one of these charts is a chart that was produced by a user on Reddit. One of these charts was produced by Paul Krugman, who is a Nobel Prize-winning economist. It's actually very hard to tell which is which. And so I think that's one of the challenges that organizations need to figure out, is how do we make sure we highlight the work that is the Paul Krugman work versus the Reddit user work, when it's not obvious being able to figure out like which is which just from looking at the data superficially. All right, so how else do we work with people? So this actually came up in one of the earlier talks, that one of the big things that we also try to do is tell a lot of stories. And this is one of the ways that we try to highlight like what is good analysis versus us just putting a bunch of charts on PowerPoint slides. So all of these things that we do about collecting data, storing it, cleaning it, modeling it, analyzing it, all of that process, the whole point of all of that is to help people communicate and understand. Is to help other people around the business make sense of what it is that we did. And you can't just put charts on a page to do that. Like I said, there was a great presentation earlier today about all of this. You have to actually do that through telling stories. One of the books I think that's actually a really great book on this is there's a book called Houston, We Have a Narrative by Randy Olson. This is more about like science more broadly, but it's about applying some of the lessons of Hollywood to telling stories in science. That science doesn't have to be some like rigorous and dry process. The way you actually get people to pay attention to it is you actually apply narratives to it. And so data scientists will often try to do the same thing, to apply narratives to the stories they're trying to tell, not to sensationalize it or falsify it, but to make sure it's something that resonates with people and that they hear. Also, this was also brought up earlier this morning, that a lot of great examples of this come from data journalism as well. So if you look at the way that the New York Times or other organizations that are news organizations try to present data, they often do it in the context of these very rich stories. So they're not just presenting a bunch of charts, but they're sort of intertwining the whole thing with stories that make it much more relatable to their readers. The next thing another way that we often communicate is through analogies. Often when you're working with analysts and data scientists, you talk through tons of analogies. It can be annoying. Some people like it. But I think it's actually a very powerful and kind of underrated story. And the reason is because the way analogies work is it's often taking like the bones of one idea and then pattern matching it to the bones of some other idea. And that's very much what you do as a data scientist. It's a lot of your job is understanding the signal from the noise and then actually pattern matching to other places where you can draw those same comparisons. And that's really what an analogy is. And so a lot of data scientists will use that as communication techniques. And to return to a Paul Krugman quote, this is something that he often pushes a lot, and I think it's a really good point, that these intuitive stories seem simple. They seem like dumbing down a complex idea, and they're not appreciative of the sort of full complexities of a problem, but they often are actually the thing that help you communicate it, and they deserve more credit as a result. One of the other things, too, that we'll often do when working with other folks is trying to understand questions, trying to understand like why people are asking things. And so if you're working with someone who's a data scientist, you'll often ask a question like, why are active users dropping? And the answer you'll get is not, here's why. You'll get something that's like, why do you want to know? The intent of that is not to be, it's not to prevent you from answering the question. It's not to get in your way. It's not to stonewall. It's to try to understand, like, what are you getting at with that question? Do you want to know why active users are dropping so we can make changes in the product organization? Is there a problem in marketing? Is it something where we think, like, there's an immediate technical problem we need to address right now? All of those things help point us in the right direction to figure out how to investigate that question. Final thing, though, the kind of corollary to this is, how are data scientists with bedside manner on that? The answer is, like, not great. That's a thing that we probably can work on. So those, like, why do you want to know, often does it come across as being sort of a super welcoming response, but often it's not intended to be that. It's often intended to be something that is trying to figure out the right way to answer a question. If we continue to move up this pyramid, the next thing is esteem. So this is what makes us feel successful. So now we're really like getting into what are the things that we like? What are the things that help drive us to do our job better, and the things that get us excited about working where we're working or working on the problems that we're working on? One of those things is moving fast. If you think about why a lot of data scientists are data scientists compared to some of the other roles that may be available to them, typically something like academia, speed is often one of the biggest reasons. And so we actually did a survey of some folks who moved to data science from academia, and asked them what's that like? What's that process been like? What's that transition like? And one of the things we heard from most of the people we talked to was it was about speed. That unlike in academia, we were looking for quick, directionally precise answers. We weren't trying to cross every T or dot every I. What we're just trying to do is get enough information to make a business decision and move on. Or they would say, hey, this pace of work is so much faster than academia. Or industry-offered projects that you need to be completed in much smaller times. We didn't have these long sort of research cycles to solve these problems. We had to do them very, very quickly. And this is often an attraction for folks into the field. It's why they move away from some of the more academic jobs, is they're looking for a way to actually move very quickly, to figure out what they think is the right answer to a problem, and then quickly move on, rather than have to go through then the sort of formalization process of how do we make sure we do this very rigorously, how do we make sure we sort of answer this question in every possible way, and get it to a sort of a publishing standard. We want to get to a decision-making standard, not to something that will get by some review board. Another thing, too, that's very motivating for folks is understanding how things work. Often this is kind of the core motivation for a lot of data scientists. Is why they get in the field in the first place. Is they have a lot of curiosities about, hey, why is the world this way? We want to understand that better, and data is often a really good path to do that. So there's this book that was actually published a while ago by Christian Rudder. It's called Dataclysm. It's about so Christian Rudder was one of the founders of OkCupid, the dating website, and it's about a lot of the different things that how people interact with each other on OkCupid and sort of what it reveals about people. And there's another book that's called Everybody Lies, that's sort of a similar thing in investigating Google searches. And I think these are the sorts of books that often are the ones that data scientists really want to read on their own time. They want to understand what are these things that are interesting patterns that emerge in the world about how people think, about how the world works, not just for understanding data for data's sake, but for understanding sort of the underlying ways that people think about things that rest beneath that. And so some examples of that are things like, I wonder if weather affects election turnout. If it rains, do fewer people show up and vote? The answer is it does, but only in non-competitive elections. So people actually do turn out if it's a competitive election, but if it's not, they won't show up. Does icing the kicker in American football work? The answer is probably not, but people actually debate this. Do younger founders, are they more successful in startups than older founders? They aren't. Older founders are actually better. And is West Virginia a state in the U.S., in the South? And people think so, unless you're from West Virginia, and then you very much say you're not. So part of the reason I put these things up is these are the sorts of questions that, if you're a data scientist, you're often oh, that was a cool question. I want to know more about that. If you're not, you may be these are boring questions. Why are you showing these in a presentation? And so that's often how we think is these are the sorts of slides that I get excited about because I can learn all these interesting things about how the world works. And that's often a thing that's kind of common among data scientists. Another thing, the last piece on this is analytical rigor. So one of the things that data scientists do care about is thinking about problems in rigorous ways. And here I don't mean in the academic sense of, again, did we build the model perfectly? Are we crossing every T and dotting every I? It's more, do we care about the caveats and nuance behind our answers? That it's often very difficult for us to just say, A is better than B. There's a lot of times data scientists will sort of riddle everything with, this suggests that. Or this seems to imply this, or we can say this with some level of confidence. They're the sort of answers that if you're a decision maker may be frustrating, but if you're a data scientist and you live in this world, it's often the thing that drives you to actually try to give the answer that most accurately represents the world. And so that's why when you're looking at things like election forecasts from folks like Nate Silver, you'll often see something like this that isn't Democrats are going to win the House. It's this very kind of complex breakdown of all these different scenarios that could happen. That it's a more rigorous answer behind this is how we think this situation will play out, and we want to present to you much richer information than just Democrats are going to win or not. And so when these things don't actually get interpreted that well, people often get frustrated. So this was Nate Silver's response to the 2016 election, which was to say, hey, the media doesn't understand probabilities. You can read this article and decide for yourself if that's the case. But that's often the way that we think about it, is we want this nuance to be reflected in our work, and when it's not, it can be frustrating or challenging. And this is also one of the reasons why like self-serve can be so challenging for data scientists, is self-serve often doesn't apply that same rigor. That when people who aren't thinking this way look at data, they often don't think in these like complicated 538 style charts. They often are like, well, which bar is bigger? I'm going to go with that. That people looking at Nate Silver's forecasts say like, he predicted all 50 states right. And his answer with that would be like, well, no, I wasn't even predicting any state. I was just saying these are the probabilities of different things happening. And so he would sort of even reject the whole premise of that. And so this is one of the places where we as data scientists have to try to figure out what's the best way for us to communicate these things in a scalable way. So the last bit of this, to move up kind of the final step of the pyramid, is this self-actualization. So this is like, what is it that fulfills us? What is it that like really makes us happy? What is it that makes us come to work every day? What is it that actually drives us to do this job in the first place? And there's only really one answer to this, and it's making an impact. So I think that the easiest way to explain this actually is through kind of a personal story for how I actually got into all of this in the first place. So back before I was working at Yammer and Microsoft, I worked at a place called the Carnegie Endowment for International Peace, which is like the world's longest name to put on a resume. What this was is a think tank for policy research. And our job was to write policy papers that we would distribute out to American policymakers to make decisions about what they needed to do. And the way that process worked is like we would write a paper. We would basically distribute that paper to people on Capitol Hill. We would hope that one person Capitol Hill would pass it along to some staffer on Capitol Hill. We would hope that staffer passes it along to like the chief of staff for some congressperson. We would then hope that that person passes it along to their congressperson. We would then like say like, hey, maybe this affects the way that they think about a problem, but we're also like one of dozens of organizations that did this. And this was like the path to us having an impact. The way in which we would actually matter is changing the mind of this congressperson. And we were like one of dozens of organizations that wrote wonky policy papers to try to do that, when in reality that person was probably going to vote along party lines anyway. The Yammer job, which was what got me into tech in the first place, was something that was very different. It looked like this. We wrote a paper, or not even wrote a paper, we found out some result, we handed it to a PM, and they said, great, we're going to go build that feature. And then not only did we immediately get to have an impact on the business to see, like, we built that feature. We said we should build it, and we get to go see build it. We actually then got to look at dashboards like these to see if it worked. We got to understand, like, hey, was that recommendation that we made the right one? We get to kind of test our theory to say, we thought this was going to drive this much change. And then when they built the feature or when they made some business change, we could actually see it and say, oh, look, it worked, or it didn't, or something was wrong with my analysis, or it was sound. And that was the kind of thing that really motivates a lot of people to get into this field in the first place, is understanding not only can they work in ways they want to work, they can do a lot of these other things that I've talked about before, but they can actually be very close to the actual impact of what they're trying to accomplish. They can actually be directly related to like the business needs. They can see the way that their decisions help change the products that people build, the decisions that companies make, the way that they market, all these different things that can affect people in the real world. And so, we ask this question a lot of folks when we're interviewing folks for the team in Mode. If I'm interviewing data scientists, I'll ask them like, why are you looking for a new job? So as a brief plug, we're hiring. But the answer that they often get is, I like my job. I'm interested in it. Like, I enjoy what I'm doing, but I want to go to a place that have more impact. I want to go to a smaller startup where the decisions that I make, I can more directly see what matters. And so that's the thing I think that really motivates folks to be data scientists, especially at tech companies and especially at startups, is they want to be able to see directly how their work changes the business, changes things for their customers, or changes things in the world more broadly. And so finally, you can see this in a lot of these job reviews and all of these things that I mentioned about Facebook. These were the things that people were looking for. They wanted influence. They wanted impact. That was the thing that either drove whether or not they liked the job or whether or not they didn't like the job. So finally, like, what do we want? What does all this mean? What are the things we're actually after? First, we want to be able to use technology, but we don't want to be prescribed it. That if you look at job listings or look at the ways that data scientists often work, we want to be able to say, get the opportunity to use whatever tool we want. We don't want to be told we have to use this technology. Technology is a tool for us. It's not something that we want to say, like, this is the thing we have to do. We want to work with data for humans, not machines or whatever like healthcare data is for. It's something that this is the world that we live in. This is the surface area of the product that we use every day is data. And so if that data doesn't feel like it's designed for us, if it was designed for some other audience that's not us, then every day we do our job can be painful. And so the more like that product, that data product is built for us, then the better we can do our jobs and the happier we are doing them. Finally, third, I guess we want to understand why. We're not trying to just describe what. It's not interesting to be able to say, like, hey, things are changing. This is falling. This is going up. This is going down. Those sorts of things are like good to know, but it's not really what motivates us to answer those questions. The real things we're trying to understand is, like, why did that happen? And if we can go even deeper than that and not just understand why, but understand, like, what are the motivations behind that? What does that tell us about the world more broadly? That's the sort of thing that can really motivate us to ask harder questions. Fourth, we want to actually deliver insights, not data. So one of the things that can really, like again, going back to some of those earlier quotes, that can really change the way data scientists think about their job is if they're asked to just pull data. They don't want to be people who are just saying, hey, write this SQL query for me, pull this list of emails for my marketing team, pull this A/B test result for my product team. They may be responsible for like understanding what that means and helping the company actually drive insights from that data, not just be the people who are like collecting and aggregating and pulling the data and handing it over to somebody else. And finally, we want to be able to drive measurable change, not just investing in what's interesting. So especially at companies that are trying to figure out like what data science looks like at their organizations, they're often kind of set people off on figure out some places where we can apply data science, figure out places where we can learn interesting things and things like that. And that's often not what's motivating. What's motivating is being able to say, we came to this conclusion, we made this decision, we built this product, and as a result, we see real change in the business that we're working on. And so if we can't do that, then people will often move on, much like that quote from that previous job board. So with that, we are right at time. And so are there any questions?
Certainly hope so.
Sure.
You can or I can. It's as you like.
Okay. Are there any new or future trends in data analysis reporting that you are excited about? I have like a biased answer to this, which is a very mode-centric answer. So one of the things I think that is missing in the data science and reporting world is these two things often exist on separate tracks. There is often like a data science side of the organization and a BI and reporting side of the organization. If you think about where these things came up, like BI has often been something that has sat under IT. It has been a thing that like originated there and is sort of slowly transitioning into more sort of data science and data analyst world. Data science was something that was never IT. It often was designed to solve a different problem. And these two things are kind of colliding where a lot of organizations have these kind of two arms where they're trying to figure out how do we do like a lot of the self-serve stuff in BI, but we also want to do a lot of this more advanced stuff in data science, and they haven't really merged yet. And I think one of the things that is most exciting to me is seeing these things come together, where there's actually ways for the organization to more clearly interact with the data science team, much the way they interact with like a BI team today. That if we can take the data science work that people do and leverage it in the same way we can traditional BI, then organizations can learn much faster, they can learn sort of much deeper questions, or answer much deeper questions, and have like a much more seamless way of actually working with their data, rather than kind of going through these different channels to do things in slightly different ways. The Excel chart is a Paul Krugman chart. Yes, Paul Krugman like exclusively uses Excel, so anybody who reads his blog, or what was formerly his blog, would definitely see that. Maslow says you can only step up the pyramid if you check the previous steps. Any opinions on how high most data scientists get? So in this case, that is a place where this analogy breaks down. That's one of the challenges of using analogies all the time, is they often don't really work. So you don't, I think, have to do everything on every step to move up. And in a lot of cases, actually, the opposite is true. We're probably focusing on the top and moving down is often most important. That if you're not focused on driving impact or not focused on working quickly and answering why, then the other pieces below it don't matter. That sort of like those job reviews were showing, fundamentally as data scientists, the impact and understanding why and answering these questions we're curious about is the reason we do the job. And without that, the kind of foundation is irrelevant. And so I don't think the other stuff is as important, but it's often the things those are like the small irritants that either drive people crazy or make people love a product or whatever the case may be, whereas the big pieces are the pieces that really motivate them to say, hey, this is like a job I love or a product I love using. How do I format my SQL statements? It was like the third one, where there's like a gutter. It's like a select, and you indent from 2 spaces, and there's a gutter, and then join, and it's the one that looks the best. What percentage of data scientists can do their job only using SQL, as in no Python or other programming languages? So this is tricky. It depends again on kind of what you mean by data scientists. And so in like the Lyft case, so Lyft in that blog post renamed what was formerly data analysts or sort of business analysts into data scientists. I would imagine a lot of those folks can sort of fully do their job in SQL. The research scientists that are the ones sort of building like the engine for saying how long does it take for your car to arrive when you request it probably cannot do that in SQL. For the most part, though, the way we see it is people kind of fluctuate between the two. Where they will use SQL all the time and then like try to layer Python on when it's valuable. So say you're trying to do some more complicated statistical analysis, you're trying to do some sort of forecast. Those sorts of things are often much easier in a tool like Python or R or whatever sort of your language of choice may be. Should a data scientist have a PhD? Certainly not necessary. I think that if you're getting into the world of the kind of like machine learning engineer or you're building like the sort of like cognitive services at Azure or things like that, those may be places where PhDs or like really, really deep expertise in some technical problem may be more important. For the data scientists that are trying to understand business problems, for the data scientists who are trying to just sort of apply some of the machine learning models that other people have built, in those cases, a PhD often isn't necessary. But it can certainly help in some cases. In other cases, though, honestly, we often see it hurting, where people are stuck in this academic context and need to take some time to get into like the business context, where all of that speed stuff I was talking about is stuff that people have a struggle, like it's a challenging transition to make. And so they'll often think like, I need to do this in an academic way, when in reality, businesses are looking for something very different. And so PhDs, I think, can be very, like it's obviously a value add, but it's something, if that's your way of thinking, it can be a little bit more of a challenge.
Okay, well, thank you very much for an insightful and engaging talk on behalf of the conference.
Oh, thank you.
And I think we spoke, Ben will be in the Prezi
Correct.
booth to answer any questions if anybody wants to talk to him a little bit more personally.